reconstruct the cuttlefish's visual pyrotechnics. Checkers, anyone? Roger's cuttlefish work hard to blend in, even to the most unnatural environments, thanks to their versatile skin.
There's no skin on Earth like a cuttlefish. These animals can change instantaneously. The diversity is fantastic. Chameleons are boring by comparison.
So how does cuttlefish skin work its magic?
Their skin is extraordinary because it has two ways to produce color and pattern.
The secret lies in specialized layers of skin cells.
The top layer are the pigmented cells that give you most of the patterning. And they are layered. They have a yellow, a red, and a brown. One little pigment cell is this little ball of color, all tightly bound up so you don't see it, and it has muscles attached to it, and the muscles can pull that pigment sac out into a little disc of color. And then when the muscles let go, it just boink, goes right back in and you don't see anything. And so it's a very simple mechanism.
Next, there's a deeper layer of iridescent reflecting cells that produce blue and green, along with red and pink. Add a white base, and the cuttlefish palette is complete.
There is no limit to the colors they can show in their skin. It's really marvelous.
Along with color and pattern, the skin can change its texture too, pushing up bumps along its surface.
Well, this enables you to fool any visual predator there is. It's much better than the Harry Potter invisible cloak. There's no comparison. This is real camouflage. They're doing it the real way.
To match their surroundings, cuttlefish rely on their eyesight. As strange as it may appear to us, their W-shaped pupils provide excellent vision.
So here you have this magnificent eye. This eye can see things very, very well.
Visual cues go straight to the brain, and the brain in turn sends instructions right to the skin cells.
It's the fastest possible way, direct control by a nerve. And so we call this electric skin, because as soon as the information gets to the brain, the information is taken out of the brain, goes to the skin and says, do this. And it's just boom, 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 boom. You know, it's really quick.
The cuttlefish's electric skin usually works for self-defense, to make it disappear into the background. But clearly, the Broad Club found a new use for its changeability.
My guess is that their skin evolved for camouflage, because as soon as they got rid of the big shell, they had to hide from predators. I think after that, the skin then evolved these patterns for communication, for mating and courtship, and in some cases even for tricking shrimps and fishes that they're going to eat.
Back in Indonesia, Mark Norman wants to know exactly what triggers the Broad Club to turn itself into the ultimate exhibitionist.
I'm very interested in this strange feeding behaviour, and so to try and understand what's going on, we need to get them to do this behaviour on cue whenever we want it to happen. By handing them live prey or decoys, they start doing the behaviour. You can start analysing what is it that sets them off, when it works best.
Mark's first offering of small crabs, their favorite food, is welcome. But it doesn't trigger too many light switches. Next step, offer a bigger lure, like a toy lobster. Will this do the trick? The lobster proves irresistible for as long as it looks alive. Once it stops moving, the broad club seems to lose its motivation. When Mark brings the lure back to life, the performance promptly resumes. But not for very long. This cuttlefish is getting bored with toys and is ready for the real thing. Cuttlefish like their meals alive. So does the size of a potential meal trigger these light shows?
Well, it seems that for smaller prey, or once they're well fed, they almost don't bother doing it. But with the bigger lures and the bigger crabs, the cuttlefish do a really good detailed display to sort of stun or to dazzle the prey long enough to slow them down, and then the cuttlefish could come in and nail them in the way it wanted to. In the case of the crabs, the cuttlefish wanted to grab it from behind so those big dangerous claws were out of the way of the attacker.
It's all about positioning. If you don't want to lose one of your arms, you've got to get just the right grip on your prey. With his next offering, Mark gets an even better view of the show.
The most interesting is when you offer a broad club cuttlefish a live animal in a glass jar. It gives you a perspective where you can move the jar around and see what it looks like from the prey's point of view. It looks like they're sort of effectively hypnotising their prey. It's fantastic. They get very excited, come in and nail the glass, get confused, the water's solid and they can't get through the water, and they continually try and get in at different angles on this glass containers.
Every cuttlefish starts off with the same hungry determination, but Mark can't fool them for long.
They learn really quickly. It only takes a few strikes before they realise they're not getting the crab. It's a total waste of time. You can sort of see them mentally turn off and sort of drift away. You get a sense there's a hell of a lot going on in those brains, but we're struggling to kind of understand how they work.
As alien as they seem, cuttlefish do share something with us: big brains. While humans have one of the biggest brain-to-body ratios among mammals, cuttlefish and octopus top the list for all invertebrates. Their large brains most likely evolved hand in hand with their complicated and changeable skin.
There are up to 20 million of these pigment cells in the skin, and to control 20 million of anything is going to take a lot of processing power. And it has to have a large brain to make all this work.
But does a big brain necessarily mean cuttlefish are intelligent? Looking for answers is Jess Purdy, a comparative psychologist at Southwestern University in Texas.
Can we know more about ourselves by studying another animal? And as a comparative psychologist, I think we can. By understanding their world a little bit can give us more insight into our world.
But how do you measure an animal's brain power?
The work with cuttlefish is at a very early stage. Not a lot of people have done learning experiments with cuttlefish, so we need to start at a very basic stage and then move up the ladder.
Here at Southwestern, cuttlefish are being tested for the most basic levels of learning. For example, if you put a wind-up plastic fish into a cuttlefish tank, at first it mistakes it for food. But once it realizes how unappetizing the toy is, from then on, the cuttlefish will ignore it. But can you teach the cuttlefish that the toy has a different meaning?
The experiment that we do with Troy the toy fish is actually asking that question.
Okay, here we go. You ready?
I'm ready.
All right, Chef.
The experiment as you see it looks very simple. You see somebody simply drop a toy fish in, and then a little bit later drop a fish in.
One question is whether or not the cuttlefish can learn to associate the toy fish with the promise of food. Sure enough, if Troy the toy is consistently joined by a real fish, then the cuttlefish will pay close attention to him. But with a separate test group, Troy swims alone, and no meal appears. So for those cuttlefish, Troy will hold absolutely no interest.
So we're seeing a difference between these two groups, and the difference is learning.
Hydrophone check. Okay, guys, we're ready to go here.
The next step is to see if the animal can learn to do something in order to get fed. Like pressing a button on a vending machine, or in their world, hitting a jar to receive a reward.
An orienting response.
Sound familiar? Remember when the Broad Club cuttlefish was shown crabs in a jar? After a few frustrated jabs, it quickly lost interest. But in this test, some cuttlefish are rewarded from an automated feeder. Strike the jar, get a snack. These cuttlefish quickly learn this trick and will keep hitting the jar. Cuttlefish easily master the most basic learning skills. So researchers need to come up with more difficult challenges if they want to really measure their brain power.
Are cuttlefish intelligent? I'm absolutely convinced that they are. So where do we go from here? Is it the level of cognitive complexity that we think these animals are capable of? Have we seen how smart they are at this point? And I don't believe we have.
For any creature, when it comes to intelligence, what matters most is how it helps you survive in the real world, so you can pass on your genes to a new generation. And there's one place where the wiliest cuttlefish play their most elaborate tricks. It's late May in southern Australia. Life on shore is just settling down for the winter. But beneath the waves, things are heating up. It's the mating season for the Australian giant cuttlefish, and thousands of them are swimming into the spawning grounds.
Giant cuttlefish coming together to breed is the most dazzling shows that they can do in these colour and shape changes. And it's spectacular when you see them just come to life in these big displays. It's sort of like they rip off their Clark Kent outfit and out comes Superman or Super Cuttlefish.
Giant cuttlefish can grow over 3 feet long. Eye to eye, the big males try to outdo each other with the most intimidating body patterns. Smaller females seem unimpressed.
usually a very secretive behaviour in lots of other animals, including other cuttlefishes, and you're lucky to even come across breeding aggregations. But to see thousands of them here is just spectacular. And so for several months, they give up the pretense of looking like seaweed or hiding in amongst the sand or the mud, and they go, bugger it, we're just going to look fantastic, and we're going to fight with each other, and we're going to impress females, and they totally ignore us. We can sit in amongst them. They can almost sit on our head, and that's when the best displays come out.
During mating, males outnumber the females, sometimes 10 to 1. And they're all looking for the chance to pass on their genes. While a female lays eggs beneath a rock, a big male tries to monopolize her, staving off the other hopeful suitors. Sometimes intimidation alone won't work, and the competitors hurl themselves into a violent and bizarre-looking wrestling match. Like an octopus, they'll squirt out an inky smoke screen when it's time for a hasty retreat. But size and strength aren't the only ways to impress the ladies. Thanks to the cuttlefish's skin morphing talents, the smaller males have a clever trick up their sleeve.
The really interesting thing in this system is actually far less obvious, and when you first dive with them, you don't see it. It takes a while before you realise what's going on. The small males who have no chance in a contest with a big male are actually doing something completely different. They're effectively cross-dressing. They're dressing up as a female by pulling in their webs and putting on this mottled colour pattern and gliding past these big aggressive males, pretending to be a female, and will come into the female underneath. What happens is, as another big male comes in and a potential conflict between these big guys starts up, the sneaker males start mating with her, successfully mate with the female, while the big guy isn't even aware of it.
The cross-dresser's success is all the more impressive because the females often play hard to get, as Roger Hanlon has seen firsthand.
These females are very picky. They reject 70% of approaches for mating, yet they only reject 30% of the cross-dressing males. So this trick gets them in the door, so to speak, past the fighting male, and they're accepted by the female.
The little guy may have crossed one hurdle, but a female's welcoming embrace alone won't guarantee reproductive success.
Mating in a cuttlefish is a strange affair. They go head-to-head, we call it. Then they join those 8 arms together from each animal. Then the male has one special arm underneath in which he reaches back and he pulls out a packet of sperm, and then he just places that packet of sperm right up amidst the arms of the female.
It's the male's job to hand over the sperm, but once he does, fertilization is up to the female. She's already mated with multiple partners and is storing their sperm in pouches under her arms.
So now this female choosiness takes on a new dimension. She not only chooses mates during the day, but she has some choice and some influence over which sperm get used. And guess what? The male can do nothing about that.
So whose sperm wins out in the end? There's only one way to find out.
We actually do paternity testing just like humans do in a court of law. And we use the same technique. And it's very precise.
Roger was part of a team that extracted DNA samples from all the participants. The mother, her partners, and the babies to find out who's the daddy.
One of the biggest surprises is that the cross-dressing males got the very next fertilization. And we did not expect this at all. The only reason we can think of is that this is a very bold, smart tactic, and the females may be acknowledging that in sort of evolutionary terms. So this trick, as strange as it seems, is very successful.
Over the course of a couple of weeks, each female will lay hundreds of eggs, sired by many fathers, filling up the crevices on the undersides of rocks. The eggs will remain there for 3 to 5 months until the babies are ready to hatch. But the newborns will be orphans. The mating season marks the end of the giant cuttlefish's life cycle, and the parents won't survive to see the birth of the next generation.
So that is a short stop, and we'll pick up with this tomorrow. And again, let's see here, I'll have a paper for you tomorrow. That activity of dissecting the squid will be on Wednesday. All right, so with that, we will catch up with you next time. Am I supposed to do that again? How does Howard do that? What is it? I don't know how you can, whatever, that's kind of like a beatbox. We'll catch up to you next time.